Roll control on the 777 is provided by 2 ailerons, 14 spoilers, and 2 flaperons. The flaperons assist in roll control in high and low speed flight. The ailerons assist in roll control only during low speed flight. During high speed flight, the ailerons are locked in neutral. The flaperons droop to increase lift when flaps are extended to positions greater than 1. As you can see from this graph, droop depends on flap position. There is no flight deck indication for flaperon droop. Each aileron and flaperon is operated by 2 hydraulic systems and 2 ACEs. Note that all 3 hydraulic systems power the ailerons and flaperons. If a single hydraulic system is lost, the ailerons and flaperons are operational. Two aileron trim switches are located on the aft aisle stand next to the rudder trim control. Moving both switches together in the same direction provides signals to reposition the ailerons, flaperons, and spoilers, and moves the control wheels. An aileron trim indicator on top of each control column shows left and right trim units. Set aileron trim right 2 units. During aileron trim, the control wheel moves in the same direction as the aileron trim switches. Spoiler panels are numbered from left to right, 1 through 14. When augmenting roll control, the spoilers work asymmetrically, and spoilers 5 and 10 are only available during low-speed operations. When used as speed brakes, the spoilers work symmetrically in pairs. To achieve symmetrical speed brake operation, each symmetrical spoiler pair is controlled by the same ACE and operated by the same hydraulic system. If a hydraulic system or ACE is inoperative, the associated spoiler pair is inoperative. In addition to being controlled by an ACE, spoilers 4 and 11 are also mechanically controlled through a cable from the control wheel. This ensures operation of these 2 spoiler panels as long as the left hydraulic system is operational. The speed brake lever, located on the captain's side of the control stand, has 3 main positions: down, armed, and up. The speed brake lever extends and retracts the spoilers. The lever also arms the system for automatic spoiler deployment on touchdown. Arm the speed brake lever for landing. Notice that when the speed brake lever is in the armed detent, the ICAS memo message, Speed Brake Armed, displays. Now let's look at 3 instances where the speed brakes operate automatically. For takeoff protection, if the speed brake lever is not in the down detent when the thrust levers are advanced for takeoff, the speed brake lever is automatically driven forward to the down position. If the pilot fails to extend the speed brakes during a rejected takeoff, pulling either reverse thrust lever to the reverse idle detent automatically moves the speed brake lever to the up position, extending the spoilers. During approach, with the speed brake lever in the armed position, The lever automatically moves to full up when the wheels touch the ground and both forward thrust levers are idle. If the speed brake lever is not armed upon landing, selecting reverse thrust moves the lever to full up. Auto speed brakes are not available in secondary and direct modes. Speed brake extension to intermediate positions is possible in flight. When the lever is aft of the armed detent, the amount of spoiler deflection depends on aerodynamic blowdown effect. Spoilers 5 and 10 are not available in flight as speed brakes. The speed brakes can be operated any time in flight, including when flaps are extended. Now let's look at a roll protection feature. Bank angle protection aids in preventing excessively high bank angles during turns. Bank angle protection is complemented by the bank pointer on the PFD changing color to amber at bank angles exceeding 35 degrees. If a 35-degree bank is exceeded, bank angle protection will create wheel forces to roll the airplane back within 30 degrees of bank. This roll command can be overridden by the pilot through the control wheel. When the excessive bank is corrected, normal operation resumes. Bank angle protection functions in both manual and autopilot operation. Now let's look at some non-normal conditions involving roll control. The ICAS advisory message Spoilers displays when one or more spoiler pairs fail to operate as signaled. The message is for crew awareness. Spoiler capability for roll and speed control is reduced. Auto speed brakes remain operative, but the speed brakes are less effective. The ICAS advisory message Auto speed brake indicates that auto speed brakes are inoperative. Do not arm the speed brake lever, as arming may cause inadvertent speed brake extension. After landing, extend speed brakes manually. Selecting landing flaps with speed brakes extended, or descending below 800 feet radio altitude with speed brakes extended, causes the speed brake extended caution message to appear. The speed brake extended message also displays when the speed brakes are extended with the thrust levers not in idle. Now remove the message by moving the speed brake lever to the armed or down position. Before leaving the lesson, let's look at 3 non-normals that could reduce control effectiveness in all 3 axes. The flight control's caution message indicates multiple control surface failures, such as partial pitch control system loss and/or partial roll control system loss. Pitch and roll response is reduced. However, full control is still retained by the flight crew. With the flight control's caution message active, the landing is made with less than normal landing flaps. The ICAS caution message Flight Control Mode displays when the flight control mode has degraded to the secondary mode. As described earlier, in secondary mode, some control functions are degraded, and some control functions are lost completely. Remember, though, you still have full control of the airplane. Simply avoid large or abrupt control inputs. The primary flight computer's caution message displays when the flight control mode automatically reverts to direct mode. When this occurs, the ACEs no longer use the PFC commands and operate the flight controls directly from pilot inputs. A guarded primary flight computer disconnect switch is located on the ADARU panel. The switch is normally left in its guarded auto position. In auto position, normal, secondary, or direct mode is automatically selected depending on the status of the system.